At the onset, I will like to thank Dr. Anil Garg for inviting me over here and to present and share some of the work which is being carried out at Shriram Institute for Industrial Research. Now, Shriram Institute has been working in the area in different sectors, particularly in biology, in environment, particularly related to air, water, in the area of material sciences, and civil. Recently, in the past 2 years, we have entered into the energy sector, and we are trying to work in the area of hydrogen ecosystem. In the recent past, we had MOUs with one of the Norwegian company, that is Greenstat, where we have worked along with them. And in collaboration, we are also working, trying to establish some of the newer projects. Now, as we all know that hydrogen is one of the lightest and simplest and most abundant chemical in the universe. And it occurs almost in limitless quantities as the constituent of water, as well as in fossil fuels, such as natural gas like methane, and other organic matter. Thank you. Thank you. Thank you, Dr. Garg. Now, the Honorable Prime Minister of India launched the National Hydrogen Mission on India's 75th Independence Day, that is on August 15th, 2021. And the mission aims to meet the climate target and making India as the green hydrogen hub. Now, there is basically increased consensus that concerted steps are to be needed to reduce the impact of global warming to less than 2 degrees. And if possible, to cap it at 1.5 degrees, higher than the pre-industrial levels. So my presentation will be basically on hydrogen production pathways, hydrogen fuel cells, and the challenges of storage of hydrogen. And after all, when we get hydrogen, when we produce hydrogen, and for the energy sector, then how the safety has to be brought in, because this is an important aspect for all the stakeholders. Next slide, please. Now, most of the hydrogen is being used in industrial processes is basically made from the carbon-based materials with significant carbon dioxide emissions. The global production of hydrogen is around 75 million tons, and most of this is basically produced by reforming natural gases, a process in which gas and water reacts at high temperature to produce hydrogen and carbon dioxide. Several pathways of hydrogen production are, here you can see, thermochemical pathways, in which natural gas reforming or steam methane reforming system is used, gasification of fossil fuels and biomass-derived liquid reforming systems. The second is the electrochemical pathways, where I think Dr. Negi has already touched, that we can use alkaline electrolyzers or polymer electrolyte membrane, that is PEM electrolyzers, or solid oxide electrolyzers. And the third pathway is the photochemical pathway, wherein photoelectrical system can be used, or even photobiological system can be used, wherein some of the bacteria like cyanobacteria can be used for the production of hydrogen. Then there are several biochemical pathways where microbial biomass conversion to hydrogen or photobiological processes, and these are essential to decide the different routes of green hydrogen. Now, Dr. Negi has already discussed about the different colors of hydrogen, so I would not go into the detail. The green hydrogen, trying to emphasize about the green hydrogen, electrolysis using renewable energy sources is the most important one. And therefore, I'll try to focus on the green hydrogen, particularly in relation to fuel cell. Now, what is fuel cell? Fuel cells are basically electrochemical energy conversion device which produces electricity, water, and heat. It has cathode and anode, which is separated by an electrolytic barrier, which is called as a membrane. Now, we have got fuel cells in different parts of the globe. Nonetheless, what is happening that these cathodes and anodes, along with the membrane, they are costing quite high, and therefore we are trying to focus how to get cost-effective fuel cell where we can utilize hydrogen, or even for that matter, alcohol as the energy material. And therefore, we are working on these two aspects in the fuel cell. We have developed at the laboratory scale the ethanol and hydrogen fuel cell for different applications, particularly from the sources like sugarcane or bagasse, you can say, where ethanol can be generated, and from ethanol we can get hydrogen, which comes into fuel cell and forms the electricity, which can be utilized for different material, including mobile computers or even the cars. We have developed both hydrogen and ethanol fuel cell, and along with the membrane, what we have developed, and here you can appreciate that the electric volt, what we have observed is 8.35, where we can have the and this is minded, this is at the ambient temperature by injecting 2 ml of ethanol. We are working on it so that it can be upscaled and utilized and can be commercially available. The second challenge is the storage. As we have heard from our predecessor speaker, that storage of hydrogen is one of the biggest problems, storage and transportation. And therefore, one alternate route is ammonia. But storage, why storage is the problem is basically because, as we all know, that hydrogen has a very low density of 0.89, which is 14 times lighter than air. And it is therefore very difficult to store, although we have got some metal hydrides material for storing this hydrogen. Nonetheless, they are very heavy, and the complex thermal management system is there, and boiling off and poor efficiency is there, expensive catalysts, stability issues, and slow response rates are there, and therefore the wide spectrum of research or the efforts are being put across to the globe to develop and optimize and upgrade the hydrogen storage facility. We have attempted to use some of the other materials related to graphene and carbon nanotubes and tried to see that how hydrogen can be absorbed on to these materials. And we have got very encouraging results that these materials can be utilized for storing hydrogen. We have worked it, and still work is in progress because efficiency we are getting low efficiency right now. We are trying to work on it, optimizing the conditions of these graphene material as well as carbon nanotubes to see that how much more absorption can take place, thereby utilizing these hydrogen storage system. As we all know, that the applications of hydrogen is basically in the industrial sector and refineries, petrochemicals, fertilizers, chlor-alkali, power plants, space research, food industries, and metallurgy. They are using hydrogen in different state of hydrogen. And the challenge for hydrogen use is the transport sector, which has already been covered by my previous speaker, where through innovation, research and innovation, we have to think of making it possible that how it can be transported from one place to another, and that too at the room temperature level or at the atmospheric pressure and atmospheric temperature level. And this is what is the challenge for particularly hydrogen, though ammonia is one of the alternate source, but research is being carried out even for the transportation of hydrogen. Now, coming to the last step of my presentation, that when we get all this hydrogen, green hydrogen, I would say, the most important thing of these storage or production or in that terms transportation is the safety aspect. The credible past accidents involving hydrogen handling in industrial processes or other applications have happened, and the severity and magnitude of such events broadly dependent upon several causes. Those may be mechanical or material failure or corrosion attack. Even the pressure might have got enhanced or enhanced embrittlement of storage tanks, the boiling liquid expanding vapor explosion, or the rupture due to impact of shock waves, or it may be due to human error. And therefore, process safety aspect needs to be dealt with utmost care, along with the training of the stakeholders. The overall aim of the process safety is identification of potential hazards and assessment of impacts of all probable and credible events to facilitate events and devising mitigation plans to reduce the risk associated with design or construction or operational stages at the facility. And the quantitative risk assessment, that is QRA, or the process safety audits, including identification of hazard scenario and consequent analysis. Various components of process safety are hazard identification, hazard quantification, risk estimation of as low as reasonable practicable, and then finally, the emergency response and the disaster management plan, which basically as per the Petroleum and Natural Gas Regulatory Board. So these are some of the important process safety aspects, and I would like to share that we have done the process safety, one process safety model, a 2D model, where LPG incident occurred in Jaipur, where we conducted the process safety, and we gave the report to the government also. But now, because hydrogen is relatively very light, what will happen that it will form a cloud if there is some burst is there. And the cloud, for the cloud measurement, you have to have a 3D model, and that has to be introduced with the process safety, which is the most important scenario for all the industrial uses of hydrogen. With this, I thank you all for your patient hearing, and would like to again thank Dr. Anil Gar for inviting me to share some of the experiments or the areas in which Shriram Institute has been working in the area of hydrogen. Thank you very much.